All right, let's take a look at the second page here. So the zero power property, all that says that any exponent raised to the zero is equal to 1. And I know that's kind of confusing. And the reason for that is let's just think about this. So let's just say you have 2 to the first all over 2 to the first, okay? Basically, what this is doing is, remember, this is the same thing as 2 divided by 2, which is the same thing as 1. So we're going to learn just down below here how to do this with a quotient. So if you have two bases that are the same, you can actually subtract their exponents, which is basically like saying 2 to the 0 power. And 2 to the 0 power, notice that's the same as 2 divided by 2, which is the same thing as 1. Okay, so that's where that rule comes from. It's basically saying you have a number divided by itself. It's not really raised to any exponent, so your answer is 1. So for example here, notice we have two bases that are the same. Adding the exponent, 4 to the 0 is the same as 1. Any variable x to the 0 is the same as 1. So basically this is like saying I had x divided by x. Anything divided by itself is just going to be 1. All right, so here, let's do it piece by piece. 3, okay, can't do anything with that. X squared, can't do anything with that. Y to the 0 is the same thing as times 1. So we're just left with 3x squared. Okay, all right, just like whenever you're multiplying two bases that are the same, you add. When you are dividing two bases that are the same, you're going to subtract your exponents. All right, so now let's take a look at our first example. This 6 has an understood of 1 here. So we have two bases that are the same, so we're going to add 2 plus 1 is 3, all over 5. Now, to get this negative 2, we have two bases that are the same. We're going to subtract the exponents. 3 minus 5, that gives me negative 2. Now remember, 6 and negative 2, you can never have a negative exponent. So you want to, since it's on the top, we're going to pop it to the bottom, make it happy. So it becomes 1 over 6 squared, or 1 over 36. Or you could also just think to this as, this is 6 to the third is 6 times 6 times 6. 6 to the fifth, there's 5 of them. Okay, and you can cancel out 3 of them. And you'd be left with 1 over 6 times 6, which is 36. So just kind of another way to think of that. X to the 7 over x squared, so you can subtract your exponents. 7 minus 2 gives you 5, so x to the fifth. Same sort of logic here. I'd have 1, 2, 3, 4, 5, 6, 7 x's, 2 on the bottom. I'm getting rid of 2 of them. So basically you're subtracting, you're saying, how many am I getting rid of that I can cancel out? And I'm left with 5 on the top. Okay, here, a couple different ways you could do this. So you have two bases that are the same. You can say negative 3, this is an understood exponent of 1, minus 1, which gives you a to the negative 4th. Can't have a negative exponent, it's on top, gotta pop it to the bottom, which becomes 1 over a to the 4th. Or what you can do is you can say, hey, this is a negative exponent, not so happy, it's on the top, let's pop it to the bottom. To make it a to the third, we have that a already there, so now I can actually add 3 plus 1 to give me 4. Okay, all right, now this one looks confusing, but let's just do it piece by piece. First, let's simplify this 8 over 12. Well, I can divide both of those by 4, so 8 divided by 4 is 2, 12 divided by 4 is 3. Now, we have x to the 7th over x to the 3rd, so I can take 7 minus 3. Okay, I have y to the 4th over y, so that's 4 minus, you have an understood exponent of 1, okay, and then you have z 2 over 4, so that's 2 minus 4, 7 minus 3 gives me x to the 4th, 4 minus 1 gives me y to the 3rd, now z to the negative 2, that's on top, so it's going to pop to the bottom, or you can think, oh, I can cross out 2 on top, and I'm left with 2 on the bottom, okay, so whatever works for you. You can do this whatever way you want. All right, now take a look at the next one. This is not any different than the multiplication rules, right? So if you have two bases, whatever you're raising it to a power, you just have to look for every single solitary base inside your parentheses and multiply each of those exponents by the power it's being raised to, okay? So we have a base of a, exponent of 1, 1 times m is a to the m. Exponent of 1, 1 times m is b to the m. Okay, so let's take a look at letter A. So this is an understood exponent of 1, understood exponent of 1. So we need to multiply 1 times 2 to get 2 squared. Okay, we have to multiply 1 times 2 to get 3 squared. Simplifies is 4 to the ninth. Okay, couple different ways you can do this one. If you want to say, hey, this is an exponent of 1, this is an exponent of 1. Let me distribute to make this 2 to the negative 2 all over 1 times negative 2, 3 to the negative 2, and say, hey, wait a second. Unhappy on top, pop it to the bottom. Unhappy on the bottom, pop it to the top. Okay, and then that simplifies to 9/4. Or you can say, wait a second, since this is a negative exponent, if I flip my fraction right away to 3/2, that will make my exponent positive. Okay, so if you have a negative exponent outside, if you flip your fraction inside of here, it makes your exponent become positive. Okay, so a couple ways you can do that. So same thing down here. You can automatically flip this to become a over 1 to the positive third, which then you do a to the third over 1 to the third, and 1 to the third is just 1. Or you can say this is 1 to the negative 3, a to the negative 3, pop it to the bottom, pop it to the top, and you are good to go. Okay. Same thing here. You can just say, hey, I'm going to flip my fraction and make this 4 over 1 to the third. Okay, 4 to the third is 64. And then, because 1 to the third is just 1. Or you can say, hey, let me do 1 to the negative 3, 4 to the negative 3. Pop it to the bottom, pop it to the top. Okay, and then you still get the same answer of 64. All right, and if you have any questions on this, feel free to let me know. There is just one thing I wanted to make sure you understood is the difference between negative 2 squared and negative 2 squared. All right, this right here, this negative is not connected to this exponent of 2. The only thing connected to this exponent of 2 is this 2 right here. This negative is just chilling. And this is the only thing you see twice, the 2 times 2. So this answer is actually negative 4 versus this answer right here, okay? This negative 2 squared, because this entire thing is in parentheses, you see everything in that parentheses twice. So you're going to see this as negative 2 times negative 2, which this one, the two negatives become a positive, and that one is actually a positive 4.